Here's problem 6.4. A 30-kilogram child rides on a circus Ferris wheel that takes her around a vertical circular path with a radius of 20 meters every 22 seconds. What is the magnitude of the resultant force on the child at the highest point on this trajectory? So we have a child going around on a Ferris wheel. And if we were to take a look at the highest point, we would note that there are a couple forces on her. There is a force of weight pulling down towards the center of the earth, and there's a normal force of the seat pushing up on her. And as a result of these two forces, there's a centripetal acceleration towards the center of this circle. And those really are the only two forces acting on her. So if I were to write Newton's second law for this situation of this free body diagram, I would say that the summation of all the forces acting on her in the y direction is equal to mass times acceleration, and that's equal to the net force in the direction of acceleration, which in this case would be her weight minus that normal force. But in this case, the question is, what is the resultant force on her? That is the net force. And the net force is the sum of all the forces acting on her. It's either the weight minus n, or equivalently, it's just her mass times acceleration. That is her net force. So, the net force will be mass times acceleration, mass times v squared over r for centripetal acceleration. And that's all what we need to find. Of course, in this case, we don't know the velocity. We know that she goes once around every 22 seconds, and hence she would cover at a constant velocity a distance equal to the circumference of that circle, 2 pi r, and do that in a time t. So that should be her velocity. So that's going to be 2 pi times 20 meters divided by 22 seconds. Hence her speed, her velocity is 5.71 meters per second. So that's the velocity we need for our centripetal force. So our net force, mass times velocity squared over r, is going to be 30 kilograms. Still in the previous problem. 5.71 squared over the radius, which is 20 meters. And that's equal to 48.9 newtons. So that is the net force acting on the child. That is the force of the weight minus the normal force, 48.9 newtons.